Every summer, European television networks broadcast the exact same sequence of B-roll. Reporters point their cameras at locals wading through historic city fountains, while meteorologists adopt a somber tone to discuss global warming and melting alpine glaciers. It is a predictable seasonal ritual. Yet these macro-level climate warnings do nothing to lower the immediate physical temperature of a 35°C living room. Beyond the immediate discomfort lies a much larger economic reality. This extreme heat is beginning to reshape where consumer demand flows. The heat wave itself is not the real story. The real story is the air conditioner. To most consumers globally, air conditioning is viewed as a standard, unremarkable home appliance, much like a microwave. However, across Germany, residential air conditioning penetration remains well below 10%. German households simply had no functional need for mechanical cooling. A deeply rooted culture of energy conservation taught families to rely instead on external window shutters, strategic ventilation, and patience. Within this deeply environmentalist mindset, chilling a living room to the temperature of a meat locker is seen as an irresponsible, wasteful luxury. Unfortunately, ideology eventually collides with the unyielding laws of physics. In recent years, prolonged heat waves have increasingly disrupted offices and public infrastructure across Europe. Meanwhile, centuries-old brick and stone buildings spend their nights radiating stored heat like industrial ovens. As traditional passive cooling methods become less effective during prolonged heat waves, people are forced to look for mechanical intervention. Google Trends appears to reflect this shift, showing rising interest in residential air conditioning across Europe. Across Europe, demand for air conditioning is rising rapidly, opening up a large and previously underdeveloped market. Standard Western economic theory suggests that such a massive surge in local demand should naturally revitalize and enrich domestic manufacturing giants. Yet, as European consumers stand ready with euros in hand, the first entity to capture this sudden windfall is not a local industrial powerhouse. To understand why Europeans resisted air conditioning for so long, we must first dismantle a widespread geographic illusion. Intuition tells most people that major European capitals like London, Paris, or Berlin share roughly the same latitude as New York, Chicago, or Tokyo. If we track the actual lines of latitude across the globe, a surprising geographical reality emerges. Berlin sits as far north as Calgary and Edmonton in central Canada. Paris aligns horizontally with Vancouver and Seattle. By any purely geographical measure, Europe's core economic hubs are located in the deep global north. This high latitude, combined with the modulating effects of the Atlantic westerly winds, historically defined the European summer, bringing mild daytime temperatures and substantial drops in temperature after sunset. Historically, even if a European afternoon felt warm, the maritime climate would reliably reset the system as soon as the sun went down. A steady influx of cool oceanic air smoothly dropped nocturnal temperatures back down to a comfortable 15 to 18 degrees Celsius. This natural cycle of reliably cool nights gradually pushed European architecture to evolve a low-tech, energy-efficient solution that remained effective for centuries. Traditional European properties feature thick stone and brick walls designed primarily to trap heat during long, freezing winters. During the summer, these same massive structures acted as an insulating shield against the sun. As solar radiation slowly attempted to penetrate the heavy stone masonry during the day, nightfall would arrive long before the heat could ever reach the interior living spaces. Residents simply opened their windows at dawn to flood the house with crisp air, then sealed the windows and drew the exterior blinds shut. The thermal mass of the walls locked the cool air inside, maintaining a comfortable climate all day. For centuries, this passive system was flawless. Because nature provided a free automatic thermal reset every night, buying an air conditioner seemed entirely superfluous. But this equilibrium has started to weaken. Over the past decade, climate change has unleashed persistent summer heat waves across the European continent. These anomalies do not just elevate daytime peaks, they also cripple the atmosphere's ability to cool down at night. As a result, the architectural philosophy that stood for centuries has run into its natural limits. Brick and stone houses built to retain heat absorb days of unrelenting solar radiation, turning them into massive residential incubators. Instead of cooling down at night, the heavy walls continuously radiate intense infrared heat inward. The home effectively transforms into a greenhouse, trapping the thermal energy with no escape route. Confronted with this new reality, European households are finally acknowledging that mechanical cooling is increasingly becoming a practical necessity. Yet, as these trapped residents decide to purchase a standard split-system air conditioner, they immediately collide with a bureaucratic barrier far thicker than any medieval stone wall, one they constructed themselves. Consequently, a portable split air conditioner called the PortaSplit has suddenly exploded into a viral phenomenon across several European countries. The machine itself looks quite peculiar. It features both an indoor and an outdoor unit, linked only by a single flat refrigerant ribbon. It hangs directly from a window frame like a clothes hanger, completely eliminating the need to drill holes through external walls. This sudden market success is driven by more than raw cooling performance. It perfectly resolves a set of highly specific, long-neglected demands imposed by European housing regulations and everyday lifestyles. Buying an air conditioner in Europe has never been a simple retail transaction. In many municipalities, strict historical preservation laws ban any modification to a building facade, while high rates of tenancy mean renters must navigate layers of bureaucratic approvals from landlords and local councils. Even if you own the property outright and the building carries no historical designation, the installation process is rarely straightforward. Standard split systems require licensed technicians to handle drilling, chemical refrigerants, electrical modifications, and drainage routing. While the actual labour takes only a day, the wait time for initial assessments, peak season scheduling, and unit delivery frequently stretches into several weeks. For families raised outside an air-conditioned culture, these structural friction points and upfront costs act as an effective deterrent against upgrading their homes. The PortaSplit bypasses this entire regulatory gauntlet. It demands no core drilling, requires no professional HVAC installation, and completely avoids the peak season scheduling bottleneck. To the end consumer, the experience feels like ordering a standard household appliance online, rather than initiating a complex residential engineering project. Every structural barrier is methodically sidestepped. It requires no permanent structural alteration, is fully removable when autumn arrives, and retains high efficiency due to its genuine split architecture, earning a verified European energy label of AA+. While it may not be the first portable split unit ever designed, it has become one of the few products to experience rapid market adoption by precisely matching its utility to the constraints of the European built environment during an active heat wave. The corporation behind this market intervention is not an established European industrial giant. It is Midea, operating out of China. But PortaSplit itself is only part of the story. To understand why this product appeared so quickly, we need to look beneath the brand. When shopping, European consumers often retain a subtle pride inherited from the Industrial Revolution. They instinctively trust historic domestic marks or the reputation of Japanese precision engineering. This consumer preference overlooks the foundational realities of modern manufacturing. In the globalized economy, the logo on the plastic casing has decoupled completely from the factory floor that actually forged it. General Electric appliances, long a symbol of American domestic life, are owned by China's Haier. Sony televisions boast top-tier image processing software, yet unscrewing the back panel reveals display glass sourced predominantly from East Asian assembly lines. The structural concentration within the air conditioning industry is even more pronounced than in consumer electronics. The core architecture of any AC unit relies on three basic elements: a motorized compressor, an inverter module for thermal control, and a network of copper heat exchangers. Look at the global manufacturing data for 2024. More than 228 million residential air conditioners were produced worldwide. Of those, nearly 81% were manufactured in China. In other words, roughly 4 out of every 5 residential air conditioners produced globally came off a Chinese assembly line. But the more revealing statistic is found in China's exports. Of the roughly 78 million units shipped overseas last year, around 70% were produced under OEM or ODM arrangements for overseas brands. Many of the inverter control boards inside these systems are assembled in manufacturing hubs across Guangdong and Zhejiang. This helps explain why brands that appear to compete on retail shelves often rely on the same manufacturing ecosystem behind the scenes. To consumers, the logos may be different, but many of those products ultimately originate from closely connected factories and supply chains in China. Western buyers believe they are choosing between distinct corporate philosophies and national heritages. The reality is far more uniform. They are buying the output of a single, massive Chinese industrial matrix, differentiated only by a customized plastic shell and a regional warranty sticker. Western commentators and media outlets frequently attribute this manufacturing dominance to a single, comfortable narrative: cheap labor. That diagnosis belongs to a previous era. If a few pennies in wage arbitrage were the ultimate deciding factor, global manufacturing would have already completed its migration to lower wage economies in Southeast Asia or East Africa. The real competitive advantage of the Chinese industrial ecosystem lies in its high-density vertical integration, its rapid prototyping speeds, and its hyper-optimized cost engineering. Consider a domestic European appliance manufacturer attempting to capture this new market by designing a toolless split air conditioner from scratch. The engineering team must cross-reference safety standards, compliance lawyers must check domestic codes, and procurement agents must align fragmented components across regions. The entire product development cycle is measured in years. Inside southern China's manufacturing clusters, product development can move on an entirely different timescale. The Pearl River Delta clusters thousands of component vendors, injection molding shops, and compressor foundries within a drive of each other. This extreme proximity slashes frictional logistics costs and compresses the distance between an initial blueprint and the final assembly line. While European municipal boards are still debating whether a new design violates historical preservation codes, container ships stacked with finished units have already cleared the Strait of Malacca, bound for the docks of Hamburg. Over the past 30 years, several core European economies intentionally outsourced their heavy industrial steps. They advanced into high-margin finance, industrial design, and premium service sectors, backed by the strictest environmental protections and labor mandates on Earth. Yet, this structural shift involves a harsh systemic trade-off. When a nation divests from low-margin, energy-intensive basic manufacturing, it simultaneously relinquishes its industrial reflex speed during an unexpected domestic crisis. The intensifying heat waves brought by global warming act as an unannounced stress test on continental resilience. The irony is stark. The more acute Europe's climate distress becomes, the more it converts into direct revenue for manufacturing centers across Asia. The retail success of a portable unit priced well north of €1,000 demonstrates a structural shift. Chinese manufacturing no longer requires rock-bottom prices to win market share. What consumers are genuinely paying for is the engineering agility to legally bypass complex permitting processes, historic building restrictions, and multi-week labour queues. Residential climate control is merely the introductory chapter. It serves as a broader structural lesson. Modern industrial competition is no longer won by whoever conceives an idea first. Victory belongs to whichever ecosystem can materialize that concept into physical inventory, refine it through iterative updates, and scale it to global retail channels ahead of the competition. This structural pattern is not entirely unprecedented. Fast fashion corporations pioneered the use of rapid response supply chains to move designs from sketch pads to store hangers in days. Today, that identical paradigm is remaking complex heavy industries, binding components, engineering, and logistics into a synchronized engine. This exact dynamic is playing out across multiple high-stakes sectors, spanning from domestic appliances to renewable energy systems and electric vehicles. Velocity, however, comes with its own structural vulnerabilities. Unrelenting price competition, compressed margins, shifting demographics, and extreme geographic concentration are now testing whether this high-speed model can remain stable over the long term. Europe spent the closing decades of the 20th century perfecting an institutional framework that prioritizes environmental quality, employee welfare, and urban preservation. China, conversely, built an industrial apparatus optimized primarily around integration and rapid industrial response. The rising summer temperatures offer no moral verdict on which model is inherently superior. They simply pose a pragmatic question. When a structural crisis manifests, who possesses the speed to answer? Is this shift merely a routine macroeconomic cycle, or are we witnessing the opening acts of a profound global industrial realignment? The question may not be whether one system is better. It may simply be which system adapts faster when conditions change. What do you think? Leave your thoughts below, and I'll see you in the next episode.